Okay, ladies and gentlemen, moving on to the second part of 12-1, we're talking about designing simulations and summarizing data from simulations. Now, it's going to be really important for us to figure out what this concept of a simulation is. I've got an image here of a car driving a simulation. We are very familiar with simulations in terms of video games, driving a car, driving an airplane. You've got those cool 3D glass things that you can wear nowadays that simulate being around dinosaurs or whatever have you. But why would we use a simulation in probability? How could we simulate a situation to make a guess about probability? Well, first, a simulation is an experiment that would be difficult or impractical to perform that can be modeled by the simulation. It should involve data that are easier to obtain than actual data you are modeling. So, for example, what is the probability that I will hit a home run on my next at-bat? Rather than setting up a baseball field and hitting a ball and getting someone to pitch for me, I can take my statistics, the probability that I normally have, the theoretical probability, say I'm 70% likely to hit a home run. I'm really good at baseball, right? So then I can find a way to simulate that using a coin or using dice to show that same probability, but doing it in experimental. So when we're designing a simulation, there are 3 steps. We have to determine each possible outcome and its theoretical probability. Then we have to describe an appropriate probability model for the situation that accurately represents the theoretical probability. That would be like if I have a 50-50 shot of something happening using a coin. If I have a 1 in 4 shot of something happening, I could use a deck of cards and the suits. Then I have to define what a trial is for the situation. So let's take a look at this. It's really hard to explain without an actual example. So in softball, Mandy is a pitcher on her high school softball team. Last season, 70% of her pitches were strikes, meaning the batter did not hit the ball. Design a simulation that can be used to estimate the probability that Mandy's next pitch is a strike. So we have our possible outcomes, strike and no strike. And we have a theoretical probability of 70% that it'll be a strike, and so not a strike would be a 30%. So in designing the simulation, it's very common that simulations use something called a random number generator. And in a second, I will show you a random number generator on your calculator that you can use. And so we're going to use a random number generator, and that will just randomly show you a number. And so we're going to call a strike any number from 1 to 7. That's 1, 2, 3, 4, 5, 6, and 7. And then 8 through 10 would be no strike. That's 70% of a chance and 30% of a chance. Okay, so let's figure out how to do this on our calculator. You're going to press the math button and the left arrow, and you're going to select the option random integer. Okay, you're going to press, we got some things covering up here. I took a bad screenshot. I'm pretty sure you need to press 1, 10 and close the parentheses. That means that you're going to get numbers between 1 and 10. Hold on one second. Okay, I pulled up my calculator. So you push the math button and you're looking for the menu that says PROB, probability. And under that, number 5 is random integer. So you're going to select that one. And you've got parentheses. You've got parentheses 1, comma 10. That's from the lower to the upper of what numbers we want to pick. And then we want one number, and that's n, and then close parentheses. And some of you might need to click the word paste if you have a newer version of the calculator. Others of you just need to click the parentheses. And then if we click enter, it gives us a random number. And I got the random number 10, which, remember, 10, it was 1 through 7 was a strike, and 8 through 10 was no strike, so I got no strike. And if you just click enter again, it'll do the exact same process again. So I got 10 again. I got 2. I got 6. I got 5. I got 8. I got 1. I got 4. And I got 10. And I got 3. So we did 10 trials to see how we would be doing. So we got 6 and 4. So our experimental probability, based on this simulation, the probability of a strike is 6 out of 10, and the probability of a ball is 4 out of 10. Not too bad, right? Now, obviously, the more you do, the more accurate your results are going to be, the closer to the theoretical probability. So let's take a look at this one. This says Larry's bus is late 60% of the time. Design a simulation that can be used to estimate the probability that his bus is late. Read through the options and see which one you think is best. Okay, hopefully as you read, you decided D was a bad choice, rolling a die for 50 trials. Because 1 through 4, that's 4 out of 6, which is 2 out of 3, which is a 66.6% probability. We need 60%. And hopefully you said no to flipping a coin, because that's 50-50. We need 60%. Looking at a random number generator for 50 trials with integers 1 through 10, 1 through 6 the bus is not late. No, we need 1 through 6 the bus is late. So letter A is the correct answer. So ways to perform a simulation. Looking at that multiple choice, you became aware that we don't have to always use a random number generator. We can do rolling the dice, we could do flipping a coin, we could spin a spinner. A spinner can have 4 options, it can have 8 options, it could have 2 options. It gives you a lot to choose with. Random number generator, most people are going to prefer that one because it's pretty easy. Pulling a card from a deck. Can you think of any others? I would be curious to know if you have other ideas. So let's take a look here. Design a simulation that can be used to estimate the probability of guessing an answer correctly on a true-false test. Well, true or false, those are 2 possible outcomes, true or false. Right? True outcomes, true, that's a 50% chance, or false, that's a 50% chance. Okay, so now that we've analyzed our outcomes, we need to design our simulation. I'm thinking using a coin would be good here. Heads being true and tails being false. Now I actually have to perform it. Maybe I'll flip the coin 25 times. And then I can find my probability based on the simulation. Let's try the second one. Main Street Market randomly gives each shopper a 2-liter bottle of one of 4 types of cola during a sale. Design a simulation that can be used to estimate the probability of each type of cola being given away. Think about it. What would you do? Outcomes. We've got 3 different kinds of cola. We're going to go Cola A, Cola B, Cola C, and Cola D. What kind of thing would you like to use for the simulation? I'm thinking cards. Deck of cards. And if I get hearts, diamonds, spades, or clubs. And that's how I will run my probability. And I'm going to do 20 cards I'm going to pull. Alright, picnics. At a picnic, there are 2 peanut butter sandwiches, 2 chicken sandwiches, a tuna sandwich, and a turkey sandwich in a cooler. Describe a simulation that can be used to estimate the probability of picking a certain sandwich from the cooler. Obviously, sometimes when you're picking a sandwich, you can't really see what's inside it. Okay, so randomly choosing a sandwich out. So we've got our outcomes. We've got peanut butter. We've got chicken. We've got tuna. And we've got turkey. Okay, so let's see here. My probabilities here. Oops, I forgot to write my probabilities in the last problem. That was 25, 25, 25, and 25. Okay. In this problem, the probabilities aren't quite as easy. I've got 2 peanut butters out of a total of 6 sandwiches. 2 out of 6 is 1/3 probability. And so I think I'm just going to write it as a fraction not simplified. 2 out of 6. Chicken is 2 out of 6. Tuna is 1 out of 6. And turkey is 1 out of 6. So I think it would be cool if we did a random number generator. Random number generator. And let's just do numbers 1 through 6. So if it's a 1 or a 2, a 3 or a 4, a 5 or a 6. And I'll generate 50 numbers. Okay? So if I get a 1, that means I got a peanut butter sandwich. If I got a 6, that means I got a turkey sandwich. I hope you guys are getting the idea. Why don't you give it a try on your own? 5 through 8 is your homework tonight.